Hello, ladies and gentlemen. Today we're going to look at the angles of polygons. And let's start with the definition of a polygon. A polygon is a closed figure formed by a finite number of coplanar segments called sides that have a common endpoint and are non-collinear. Each side intersects exactly two other sides only at endpoints. All right. Also, we're going to learn about a diagonal of a polygon. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. There's two types of polygons that we need to be concerned about. One is a concave polygon, and that is a polygon in which at least one diagonal, or concave, at least one diagonal passes through the exterior. For instance, if you had this polygon, this four-sided figure, the diagonal connecting these two vertices would lie outside of the polygon. Now, at the very minute you stop that from happening, then you no longer have what we call a concave polygon. You have a convex polygon, and that is a polygon in which no diagonal passes through the exterior of the polygon. All right, now, if you were to take a polygon with any number of sides and put a point inside the interior of that polygon, I'm just going to sketch a polygon, all right, and I'm going to put a point somewhere inside the interior of it. And if you were to connect that to that point to each endpoint of all the sides, all right, that would separate that polygon into n triangles, where n is the number of sides, all right? And if you were to multiply 180, because each angle of a triangle has 180 degrees in it, and you multiplied that times n, that would give you the sum of all the angles of those n triangles. Well, to get the measures of the polygon, you would need to subtract all of this right here. Well, all of that adds up to 360 degrees. So you would have to subtract that out, and that would give you the measure of each angle, each n angles of your polygon, all right? Now, of course, each of those two terms there have a common factor of 180, so if you factored that out, it'd be 180 times n minus 2. And those are the expressions that we use to find the total sum of the n angles of the interior angles of any polygon, any convex polygon. All right. So the sum of the measures, the sum of the interior angle measures of an n-sided convex polygon is n minus 2 times 180, or you can write that 180 times n minus 2, same thing, or 180n minus 360. You write it whichever way you like, okay? All right, now another thing we need to talk about when we're talking about polygons is classifying polygons, all right? That's in your book on page 57. All right, if you have, of course, 3 sides, that's a triangle. If you have four sides, that's a quadrilateral. If you have 5 sides, that's a pentagon. If you have 6 sides, that's a hexagon. All right, here's a hexagon. I think I got the, let's see, 2, 4, 2, oh, hexagon, 3, 4, 5. I need another one. Hold on just a second. I'll get a hexagon here. Okay, a hexagon has 6 sides. All right, a heptagon has 7. All right, let me get this thing linked here. Hold on one second. Here's a hexagon. Okay, there's your hexagon. And an octagon is 8 sides, a nonagon, and those are on your page 57 in your textbook. Nonagon is 9, decagon is 10, hendecagon is 11, a dodecagon is 12, and anything greater than 12 sides, we just, like for instance, a 13 side, we call it a 13gon. All right, so let's move on. Let's turn the page on our notes, and so we're going to talk about some special polygons. Of course, we have an equilateral polygon is a polygon in which all sides are congruent. An equiangular polygon is a polygon in which all angles are congruent. And if any time you have a polygon that is both equilateral and equiangular, that polygon is called a regular polygon. It is a convex polygon that is both equilateral and equiangular. All right, now let's look at these notes here. In these notes it says, find the sum of the measures of a 30gon. Well, remember that 180 times n minus 2 will give you the sum of the measures of any convex polygon. All right, and by the way, from now on in this book, when we talk about a polygon of any kind, we're assuming that it's a convex polygon unless we're told otherwise, okay? All right, so let's take 180 and multiply it times, if it's a 30gon, n is the number of sides, and that's 30. And if we take 30 and subtract 2 from it, that would give us 28. So this would be equal to 180 times 28. And 180 times 28 would be 5,040 degrees. That would be the sum of the measures of the 30 angles of any convex 30gon. All right, let's look at number 2. Number 2 says, find the number of sides of a regular polygon given that the measure of each interior angle is 135 degrees. Okay. Well, we didn't talk about this a minute ago, but anytime you have a polygon that's equiangular, all right, what you can do is do n minus 2 times 180 to get the sum of all the angles, and then divide that by n to get the measure of each angle, okay? And that's what we could do here. Since we know the measure of each angle is 135, we can do n minus 2 times 180 divided by n, and that will be equal to 135. All right, and you've got a couple of options here. You could, if you wanted to, multiply each side by n, and go ahead and distribute. That's what I'm going to do. That'll give me 180n minus the 360 equals 135n. And if you want, you could subtract 180n. That's what I would probably do. Subtract 180n from both sides. That would give us negative 360 is equal to negative 45n. Divide each side by negative 45, and that would give us n is equal to 8. So this would be an octagon. All right, octagon. So there's your work for number 2. All right, let's go down to number 3. It says find the value of x. Well, this is a 1, 2, 3, 4, 5-sided figure, which we call a pentagon. And if you were to take 180 times 5 minus 2, you would get 180 times 3, well, that's 300 plus 240, which would be 540 degrees. All 5 of these angles must total 540 degrees. Okay. All right, so we could say, all right, the measure of angle A plus the measure of angle B plus the measure of angle C plus the measure of angle D plus the measure of angle E all adds up to 540 degrees. All right. And now most of us wouldn't do that, but we could. I want you to know that. All right. Most of us would just say, okay, I'm going to start with this 4x. So 4x plus 10. I'm going to add to that 6x plus 10. I'm going to add to that 5x minus 5. I'm going to add to that 4x plus 5. I'm going to add to that 7x, and that still has to add up to the sum of those 5 angles, 540. And then we'll simplify that left-hand side. 4 and 6 is 10, plus 5 is 15, plus 4 is 19. 19 plus 7 is 26x's, so 26x. 10 and 10 is 20, minus 5 is 15, plus 5 is 20. So plus 20 has to add up to 540. So next we need to subtract 20 from each side. That would give us 26x on the left is equal to 520 on the right. And then we just need to divide each side by 26, and that would tell us that x is 20. All right, and now it's just wanted us to find x. That's all we need. We could do that, put our answer down right there. We're done with that problem. And then we can go on to the next one. All right, let's turn the page. the polygon exterior angle sum. If you, the sum of the exterior angle measures of a convex polygon, one at each vertex, is 360 degrees. And let's say you had 5 sides, okay? If you have 1, 2, 3, 4, 5 sides, and you extend each side, all right, in the same direction preferably, all right, you would get 5 exterior angles. 1, 2, 3, 4, 5. The sum of those 5 angles will always be 360 degrees, no matter if there's 5 of those. If you did a hexagon, you'd have 6 exterior angles, 1 at each vertex. And that's what we mean by an exterior angle, is just extend one side, and the segment formed by that extension and the other side, the line containing the other side, will create what we call an exterior angle. All right? Number 4 says, find the sum of the measures of the exterior angles of a 36gon. Well, we already know that answer. We know that answer from the theorem is 360 degrees. There's no work that needs to be done. Now, let's look at number 5. Find the measure of each exterior angle of a regular octagon. All right, well, we know that in an octagon, all right, there's a couple ways you could do this. You could say, okay, I'm going to find the interiors, all right, and then subtract it, because the interior and exterior will always be supplementary. Or we know that each one of those, the exteriors are going to be congruent because of the fact that the interiors are all congruent to each other. So we could just take 360 and divide that by 8. If we do, we'll get 45 degrees. That's the easy way to do that. Okay, all right, number 6 says, if a regular polygon has an exterior angle measure of 30 degrees, then how many sides does it have? Well, you know that 360 divided by the number of sides, if it's regular, will give you the angle measure 30. All right, so you could make a proportion out of it. Do your cross product that contains the variable, all right, 30n, and that would be equal to the other cross product, 360. Divide each side by the coefficient of n, which is 30, all right. N would be equal to 120, the zeros cancel, my fault. All right, so 12 sides. So we would be looking at a dodecagon. A dodecagon. 12 sides. Excuse me, I'm sorry about that. Okay, all right. That's pretty much all we needed to do today. All right, if you have any questions about your work, please show up in a Google Meet, email me, or call me, or whatever you need to do. Thank you, and have a good day.